Hello again and welcome back. For this video we're going to talk about the intercepts of graphs. This is lesson 3.4. This is going to be a 2-day lesson, so it's going to be a 2-video part. The first part we're going to talk about intercepts of functions in intervals where the functions are positive and negative. And on the vocabulary part we're going to talk about x-intercept, y-intercept, and where the graph is positive and negative. And when we do these two here, you really need to know the difference between domain and range. Remember that domain is the x values and range is the y values. So for our learn topic here, it says the intercepts of graphs are points where the graph intersects the axis or an axis. The x-intercept is the x-coordinate of a point where the graph crosses the x-axis. So looking at the graph over here, the dot here, here, and here, those are all x-intercepts. That's where they cross the x-axis. And one unique feature that all three of those points have in common is at that location, all the y values have a 0 value. So all the range values of those points are 0. So it's some x value followed by 0, and that's your x-intercept. The y-intercept is the y-coordinate of a point where it crosses the y-axis. So the y-intercept, this graph only has one, which is down here. And every y-intercept on any graph will always have the ordered pair of some 0 for x followed by a value of y. So you'll notice how these two points kind of change position. The 0 is in the y position for the x-intercept, and the 0 is in the x position for the y-intercept. A function is positive when its graph lies above the x-axis. So looking back at our graph again, this portion up here, all this stuff that's above the x-axis, that's where the graph is positive. And this entire portion down here below the x-axis is where the graph is negative. Example 1, intercepts of the graph of a linear function. So use the graph to estimate the x and y intercepts of the function. Describe where the function is positive and negative. All right, so the x-intercept is one they're asking for first. That's the point where the graph crosses the x-axis, and it crosses right here. And it looks like that is at the position of 3, 0. And the y-intercept is up here, and that appears to be at 0 for x, 6 for y, so a domain of 0, range of 6. The function is positive when its graph lies above the x-axis. So everything that's above the x-axis is where my graph is positive. However, it only occurs along this portion of the line where all the x values on this line are less than, because they're going to the left, of the intercept. So this is positive, this graph is positive when x is less than 3. So we have a domain where it's less than 3. A function is negative when its graph is below the x-axis. So all the portions down here, but all the x values that are on this part of the line are where x's are bigger than 3. So the function is negative when x is greater than 3. And you notice how it's not equal at either location, and that's because when x equals 3, it's right on the x-axis, which causes a y value of 0, and 0 is neither positive nor negative. Go ahead and pause the video and attempt to check here. Okay, it says use the graph to estimate the x and y intercepts of the function and describe where the function is positive and negative. So the first thing we want to do is figure out where the intercepts are. So we've got an intercept right here, which is going to be a -2, 0. That's the x-intercept, so the x-int. So x-intercept of -2, 0. So this one's -2, 0. This intercept is -6, 0. So that one's not right. This one's a -2, 0. And the bottom one's a -6, 2, 0. So it's either choice A or C. Now let's look at the intercept for the y. So the y-intercept is down here, and that's at 0, -6. So the y-intercept is 0, -6. Well, unfortunately, both these options left over have a 0, -6 for the y-intercept. So what's going to be able to tell us which graph matches the letter, or the answer, is where's the graph positive, where's the graph negative. So if we look at the top, this portion up here above the x-axis is where the graph is positive. And you'll notice that all the values on this side are going to the left of the intercept. Well, the intercept was -2 there, so we're looking for values that are, of x that are less than -2 for positive. So down here, all these are negative, but only when it goes to the right of -2. So that would be x's that are greater than -2. So we've got to look for our answers. Choice A says where x is greater than -2, and that's positive. So positive is x is greater than negative 2? Well, we have x is less than negative 2, so it can't be this. Therefore, it must be C. And if we check our answer here, you'll see positive where x is less than negative 2, just like this one over here, and then negative where x is greater than negative 2, which is right here. For example 2, they want us to find the intercepts of a graph of a nonlinear function, so that just means it's not a straight line anymore. We're just going to do the same thing before. We're going to find the x, y intercepts, where is it positive, negative, only on a curve. So the x-intercepts we're going to find first. The x-intercepts are where it crosses the x-axis here and here. And even though the ordered pair for this point right here is negative 4, 0, I don't have room to write that on the line, so I'm just going to take the x value, which is negative 4, and write it in there. And we just have to remember at that location, the value of y is 0. And the same thing over here with the other x-intercept, which is at 3, 0. But I'm only going to put the x-coordinate, which is 3, and remember that the y-coordinate at that location is 0. There's only one y-intercept. It's down here, and it appears to be at 0, 12. And again, I don't have the room to write that on here, but I'm going to stay consistent the way I wrote these up here. I'm going to write just the 12 on there, so the y-intercept is 12. But remember, it is an ordered pair at 0, 12. Okay, to find where the graph is positive, I'm going to take a moment to explain how we know where it's positive and why it's positive. The book doesn't seem to explain very well. The graph is positive when all the y values equal a positive number. So that's why when we look at the graph, we're looking for portions that are above the x-axis because all y values above the x-axis are positive. So how do I describe this left-hand side right here where all the y values would be positive? Well, all those y values would be positive so long as they are to the left of this intercept. Well, the intercept was negative 4 there, so it's where x's are less than negative 4. At that point, every y value along that line will be positive. When we look at the other side, this side over here where it's positive, that occurs whenever the y values or the x values are bigger than this intercept, which is 3. So x's are greater than 3, which means every point on this side will have a y value that is positive. So where is the graph negative? Well, that will be anywhere where the y values are negative numbers. And of course, that means everything underneath the x-axis. So all those values down there are negative, but you'll notice all those values down there of negative have x values that are between the negative 4 on this side, on the left side, and the positive 3 on the right. So it's between negative 4 and it's between 3. Go ahead and pause the video. Okay, for this one we want to use the graph of the function to determine the key features. Okay, so part A, determine whether each ordered pair represents an x-intercept, y-intercept, or neither. Okay, so 1, 0, so that's to the right 1, up 0, so that point would be right here, and that would be an x-intercept. The next one is 0, 1, so 0 for the x, 1 for y, we'll put this point right there, so that would be neither. For part B, describe where the function is positive and negative. Okay, so positive is up here on the graph, and it occurs when it's between this value, which appears to be a 1, and between this value here, which appears to be a 4. So it's when the x values are bigger than 1, but smaller than 4. So that's what I'm going to look for first. Positive bigger than 1, smaller than 4. Positive when x is between 1 and 4. That's another way of writing it. So those are two options. We got another option here. X is between 1 and 4. So we actually have three options here. That first one's not correct. So where's the graph negative? Well, that's negative when it's below the x-axis. And on this left-hand side, we're looking for values where x is smaller than its intercept up here, which is 1, so smaller than 1. And on this side of the graph, all the x values are greater than the intercept of 4, so x is greater than 4. So x is less than 1, and x is greater than 4. If I look at choice D, it looks like less than 1, greater than 4. That looks like that might be an answer there. Let's look at choice C. It says negative where x is greater than 1. Nope, we know it's got to be less than 1, so that one's not right. And then negative when it's between 1 and 4. No, it's not between 1 and 4. So it's got to be choice D. Example 3, we've got a little word problem here. It says sports. The graph shows the height of a ball for each second x, so x is seconds, that it is airborne. And it looks like y values are height above the ground in feet. Use the graph to estimate x and y intercepts of the function, where the function is positive and negative, and interpret the meanings in the context of the situation. Okay, so the x-intercept, there's only one because this graph does not go into quadrant 3, so this side of the graph over here doesn't exist. So there's only one. It's right here, and that would be 9. And what does that mean? Well, that means the ball will hit the ground after 9 seconds being in the air. The y-intercept is, and it looks like the y-intercept is right here, which is 4. Remember, the y-intercept is measured in feet, so that's probably above the ground, so that is 4. And this means that at time 0, because down here, if we go straight down, the x-coordinate there is 0. At time 0, the ball was at a height of 4 feet. So basically, that's like the starting point of the graph. So at 0 seconds, the ball is already 4 feet above the ground. The function is positive when x is between, okay, the graph is positive for the entire graph. Remember, it doesn't go beyond quadrant 1 here. So this entire graph is positive, but it's positive between where it starts over here on the left-hand side, which is 0, and where it ends on the right-hand side, which is 9. So it's positive between 0 and 9 seconds. And one thing that confuses people on this positive and negative concept is we are looking for the y values to be positive or negative, but we're describing it using the domain values where that occurs. So that's how you have to keep that in mind. Okay, so the 0, 9 means that the ball is in the air for 9 seconds. No portion of the graph shows that the function is negative. And that's because we're only looking at quadrant 1, and most real-world scenarios only deal with quadrant 1, avoiding negative x and negative y values. Go ahead and pause the video and attempt to check. Okay, for this check, the graph shows the number of people y at a gym x hours after the gym opens. So this time is in hours after it opens, and this is the number of people that are there. So part A, use the graph to estimate the x and y intercepts. Okay, so the x-intercept is right over here, and it looks like it's around 12 hours, so the x-intercept there would be 12, 0. And the y-intercept, now y-intercept we already know is going to have a 0 here, so the y-intercept, when we look back at the graph, this is not going by 40s, it looks like it's going by 20, so it looks like 20 people, and that's at 0. So probably 20 people showed up right when the store opened, or right when the gym opened. Part B, which statement describes the meaning of the x and y intercepts in the context of the situation? Select all that apply. Well, I think I may have answered part of that. Okay, so there are 20 people at the gym when it opened. That looks correct. In fact, that's what I just said, so you can put A. It does say select all that apply, so there's probably another one. The gym closed after 20 hours? No, that's not what that is. The gym closed after 12 hours. That's where the intercept is. Because when it closes, it's down here at 0 people, so it's probably C. There were 12 people at the gym when it opened. No, I don't think there was 12 people. If I look back at the graph, it looked like there was 20 people because the intercept was 20. So that's not true. So A and C appears to be the answer. Okay, for our last example for part A, it says find the intercepts from a table. Violet starts the semester with $150 in her student lunch account. Each day she spends $375 on lunch. The table shows the function relating the amount of money remaining in her lunch account to the number of days Violet has purchased lunch. So part A, find the intercepts. We want to find the x-intercept. Now remember, the x-intercept is where the y value is always going to equal 0. So the x-intercept is, I go down the y column, so I'm going this way, and I find the intercept right here, which is 0. So the x-intercept is whatever the value of x is at that location, so the x-intercept is 40. The y-intercept occurs when x equals 0, or the domain is 0. So if I come through, I'm looking, oh, my very first one is 0. So the y-intercept is whatever the y value is at the x equaling 0, so 150. That's probably in dollars. Part B, describe what the intercepts mean in the context of the situation. Okay, so the x-intercept means that after buying lunch for the x-intercept is down here at 40. So it's 40 days. Violet will have, now this is the Y value, $0 left in the account. Or it will take Violet 40 days to use all the money in her lunch account. The y-intercept means that Violet's lunch account has 150. Now the y-intercept is the actual number, 150, after buying lunch for 0 days. So that's like the starting point. And you're going to find that a lot of our word problems, the y-intercept tends to be a starting point on our graph, or the beginning balance of her lunch of her lunch account is $150. Go ahead and pause the video and attempt the check. Okay, for this check, Ashley received a gift card to the movie theater for her birthday. The table shows the amount of money remaining on her gift card Y after X trips to the movie theater. Part A is find the y-intercept. Again, the y-intercept is when the X value is equal to 0. So if we're finding Y, X equals 0. So if we look at it in the X column, it's 0. Therefore, our y-intercept is 90. So 0, 90. Find the x-intercept and describe what it means in the context of the situation. Okay, the x-intercept occurs when the y value is 0. Then the x-intercept is the x-coordinate at that location, which is 10. So if we look through our answer choices, we're looking for 10, 0. So we got a 10, 0 here. So it can't be choice B. 10, 0 here. Can't be choice D. Okay, let's see what they say. Choice A says the initial balance of the gift card was 90. That's at the x-intercept. Well, the x-intercept has an output of 0. If we look back at the top, that's the balance. So at the x-intercept, her balance is 0. So the initial balance of the gift card was 10. That's not what that means. Part C, or letter C. Letter C says after 10 trips to the movie, there will be no money left in the gift card. And that's exactly what that intercept is telling us. So the answer here is choice C.